Right now, as you sit in your driveway, your Toyota is quietly costing you money you have absolutely no reason to spend. The rear brake pads on your Camry, your RAV4, your Highlander, your Tacoma, they are wearing down, just like they always have. Friction material against rotor, same as it has been since the first automobile rolled out of a factory floor over a century ago. That part has not changed. What has changed is that somewhere between 2014 and 2017, Toyota's dealership network discovered that they could install a small electric motor inside your rear brake caliper, call it innovation, call it electronic parking brake technology, and in doing so, permanently lock the average car owner out of one of the simplest maintenance jobs in all of automotive history. Today, I am going to give you back what they took. I am going to walk you through the exact sequence that Toyota's own factory engineers built into your car, a sequence that the dealerships have never once mentioned, that no service advisor has ever voluntarily disclosed, because revealing it to you would cost them approximately $600 every single time your brake pads wear thin. This information destroys their business model. They know it. And after today, so do you. To understand why this matters so deeply and why the suppression of this knowledge is so deliberate, you have to understand what is actually happening inside your rear caliper. Traditional brake calipers are hydraulic. When you press your brake pedal, brake fluid travels down a line, enters the caliper, and pushes a piston outward. That piston squeezes the brake pad against the spinning rotor. When you release the pedal, the fluid pressure drops. A small rubber seal inside the caliper board deforms slightly and then springs back, pulling the piston away from the rotor by a fraction of a millimeter. It is elegant, it is mechanical, it is something any human being with basic hand tools and about 40 minutes of free time can manage comfortably in their own driveway. To swap the pads, you simply compress the piston back into its bore using a small tool or even a large flathead screwdriver. And the new, thicker pads slide right in. Total cost of entry for a quality set of rear pads, $30 to $60 at any parts store. Total labor, yours, and it costs nothing. Now, imagine that, instead of a simple hydraulic piston, Toyota placed a small electric motor inside the rear caliper. So, this motor connects through a series of gears to a threaded spindle. When you engage the electronic parking brake by pulling that switch inside your cabin, the motor spins, the spindle rotates, and the piston threads itself outward like a corkscrew, pressing the brake pad firmly against the rotor and holding it there with tremendous mechanical force, even after all electrical power is removed. The system is genuinely clever. Engineering, the motor generates torque, that torque turns a worm gear, and the worm gear drives the spindle. Because worm gears are not backdrivable by design, meaning you cannot push on the output side and make the input rotate in reverse, the parking brake holds absolutely without drawing any continuous electrical current. The car can sit for weeks on a hill, battery completely dead, and the rear brakes remain mechanically locked. From a pure engineering standpoint, it is a brilliant solution to the problem of holding a vehicle stationary. But here is the trap, and this is where the money is stolen from your pocket. Because the piston is threaded onto that spindle, rather than simply pushed hydraulically, you cannot compress it back into the bore by pressing on it. And if you try, you will strip the spindle gears or burn out the motor entirely. The piston must be retracted by reversing the electric motor, spinning the spindle in the opposite direction, threading the piston back in the same way it came out. Without doing this, there is physically no way to slide new brake pads into the caliper. The old pads wear to the rotor, the caliper is full, and the new thicker pads simply will not fit. You are stuck. Unless, of course, you know something the dealership is counting on you not knowing. Here is the history they buried alongside the technical manual. Toyota began rolling out electronic parking brake systems across its North American lineup in earnest, starting around 2013 and 2014. The RAV4 transitioned. The Highlander followed. By 2016, the Camry was on board. By 2018, a majority of new Toyota vehicles in the United States featured EPB as standard equipment on rear axles. Now, Toyota engineers, the actual people who design these systems inside actual engineering facilities, knew that someday these vehicles would need brake service. They are engineers. They think about maintenance intervals. They think about the field technicians who will work on these cars for the next 15 years. And so, like responsible engineers always do, they built a manual service procedure directly into the system. It is not buried in a special module that requires a laptop to access. It is not hidden behind a proprietary software license. It is encoded into the behavior of the EPB switch itself, a physical button already in your center console, connected directly to the EPB control module, accessible to any person who sits in the driver's seat. The dealership network made a different decision. Almost immediately after these systems began arriving on American roads, the service department training materials emphasized one thing above all others. Customers need our TechStream diagnostic computer to service these brakes. TechStream is Toyota's proprietary dealer diagnostic software suite. A full setup costs somewhere between $5,000 and $12,000 depending on the hardware configuration. Independent shops either do not have it, have purchased an aftermarket clone of questionable reliability, or charge a premium for its use. Home mechanics have essentially no legitimate access to it whatsoever. This created what dealership service managers quickly recognized as a captive audience. You drive in with worn rear pads. They tell you the job requires TechStream to retract the calipers safely. They quote you $500, $600, sometimes $800 for what is, at its core, a 20-minute pad swap. And because you have no reason not to believe them, you pay it. Multiplied across millions of Toyota owners in the United States alone, across millions more in Canada, Australia, the United Kingdom, and every other right-hand drive and left-hand drive market where Toyota dominates, this single piece of omitted information generates hundreds of millions of dollars in captured service revenue every single year. What makes this particular suppression so breathtaking is that the manual sequence is not even subtle. It is not some obscure engineering Easter egg buried in a forgotten section of a service manual from 2009. It works cleanly and reliably on virtually every Toyota and Lexus vehicle with a factory EPB system. The engineers who designed it intended it to be used. They built it in because they knew, with absolute certainty, that someday a technician in the field, far from any dealership, far from any laptop running TechStream, would need to change those brake pads. The sequence exists because good engineers prepare for the real world. Now here's the proof that this was always known internally. Commercial fleet operators, the people who run hundreds of RAV4 hybrids as corporate lease vehicles, the municipal governments running fleets of Camrys as patrol cars and administrative vehicles, have been performing this exact manual sequence for years. Fleet service contracts are negotiated at thin margins. Nobody running a fleet of 300 Toyota vehicles is paying dealership rates for brake jobs. Documented fleet maintenance logs from municipal vehicle pools in several American cities show rear brake service completed by in-house mechanics, no dealer involvement, no TechStream computer, at a cost of materials only. When automotive journalists and independent mechanics began investigating EPB service procedures around 2019 and 2020, they found that Toyota's own overseas market owners' manuals, particularly those distributed in certain European markets, contained abbreviated references to a manual caliper reset procedure for emergency use. The American market documentation conveniently omitted this same information. The difference in documentation is not accidental. Markets with stronger independent repair rights legislation received more complete information. The American market, where dealer service contracts are enormously profitable, received the version that sends you back to the dealer. Now, I am going to give you what the dealer charges $600 to pretend only they can provide. This is the complete procedure. You will need nothing except your own key and your own hands. Start by parking the vehicle on flat ground. Engage the conventional wheel brakes, meaning press your foot brake firmly before you do anything else. You do not want the car rolling while you work. Now, reach into the car and set your ignition to accessory mode. On a Toyota with a traditional key, this means turning the key one click forward, stopping before the engine cranks. On a push-button start Toyota, this means pressing the start button once without your foot on the brake pedal. You are not starting the engine. You are simply waking up the electrical system, powering the EPB control module, giving it the ability to receive the sequence you are about to input. Locate your EPB switch. It is the switch in your center console or center stack area with the letter P inside a circle and parentheses on either side, the universal parking brake icon. On most Toyota models, it is a small rocker or pull-type switch. Familiarize yourself with the two directions of operation before you do anything else. Pulling the switch up or toward you engages the parking brake. Pushing the switch down or away from you releases it. Make sure the electronic parking brake is currently in the release position, meaning the parking brake is off and the yellow P indicator on your dashboard is not illuminated. Now perform the following sequence deliberately but without hesitation. Press and hold the EPB switch in the release direction, pushing it down. While holding it in the release direction, use your other foot to press the brake pedal firmly. Continue holding both. After approximately 3 seconds, with both inputs held, begin cycling the EPB switch rapidly. Push it down for the release, then pull it up for engage, then push it back down for release again. You are looking for between 3 and 5 rapid cycles of this push-release motion, all while keeping your foot pressed firmly on the brake pedal. On many Toyota models, the exact trigger is holding the release position, pressing the brake, and then performing 3 rapid cycles within a 5-second window. The moment the system enters service mode, your dashboard will communicate this to you clearly. The yellow parking brake indicator light, that P with the parentheses, will begin flashing. On some models, it flashes a steady rhythm. On others, it illuminates in a particular pattern distinguishable from its normal solid on or solid off states. The flashing yellow P is your confirmation. The EPB control module has received the sequence, recognized it as a service command, and is now actively running the electric motor inside each rear caliper in reverse, threading those pistons back into their bores. You can often hear this happening if the car is quiet. A faint whirring or clicking from the rear of the vehicle, lasting approximately 5 to 10 seconds, is the motors retracting. Once the motors stop and the yellow indicator settles into its flashing pattern, the calipers are in service position. The pistons are fully retracted. You now have the clearance to remove the old pads and install new ones exactly as you would on any conventional hydraulic caliper system. When the new pads are installed and the caliper is reassembled, you must bring the system out of service mode by pressing the brake pedal firmly and then pulling the EPB switch up to engage the parking brake normally. This allows the motor to run forward, threading the piston back out against the new pads and seating everything correctly. Cycle the parking brake on and off 2 or 3 times from inside the car with the ignition on to ensure the system self-calibrates to the new pad thickness. Test the parking brake on a slight incline before driving. The entire process, from jacking the car to driving away, takes the average person with no professional mechanical training approximately 60 to 90 minutes. The brake pads themselves cost between $30 and $80 at any national auto parts retailer. You have just done a job the dealership charges $600 for. If you are worried about sourcing pads, any major parts retailer carries rear pads specifically sized and rated for your Toyota model year. Search by your year, make, model, and the phrase rear ceramic brake pads for the best balance of stopping performance and low dust. Brands including Akebono, Bosch QuietCast, and PowerStop all produce direct-fit rear pads for the vast majority of Toyota EPB-equipped vehicles that are available without any dealer involvement, without any special ordering process, sitting on the shelf at your local store for between $30 and $80. What I need you to do right now, after you close this video, is share it. Not as a favor to me, as an act of protection for every Toyota owner you know. Your neighbor just got quoted $640 for rear brakes. Your sister's Highlander has the rear pads sitting at 2 millimeters. Your coworker has been putting off brake service for 4 months because the estimate from the dealer felt impossible. Every single one of these people is being financially exploited by the deliberate omission of a procedure their own vehicle was factory engineered to perform. The algorithm is not going to promote this video. The automotive service industry spends significant resources ensuring that information like this stays in corners of the internet where most car owners never find it. The only distribution mechanism that works is you. Forward this. Share it to your family group chat. Post it anywhere. Toyota owners gather online. Subscribe to this channel, not as a courtesy, but because what I am releasing next will make today's video look minor by comparison. In the next video, I am going to show you the hidden recalibration sequence that resets your Toyota's throttle body without a single dealer visit, a procedure that Toyota service advisors are actively trained to tell you requires a $250 diagnostic appointment and that you can perform in your own driveway in under 8 minutes using only the accelerator pedal and the ignition switch. If your Toyota has ever hesitated on acceleration, surged unexpectedly at idle, or felt sluggish after a battery disconnect, that video is going to change everything. Hit the notification bell. This information is coming, and the dealers already hate that I am making